Hello and welcome to an overview of how Cilium works with gRPC. Cilium is an open source project that provides microservices-aware network security. What that means is that Cilium sits inside the Linux kernel and sees all the traffic between the containers you're running on platforms like Kubernetes, Docker, and Mesos, and provides you firewalling capabilities between your containers. But because Cilium is microservices aware, it understands not just the IPs and ports, but also application layer protocols like HTTP, Kafka, and gRPC. In this demo, we'll focus on gRPC. Everything we're talking about here is something that you can follow along with yourself by going to www.cilium.io/try-grpc. Here we'll use Kubernetes as the container orchestrator to deploy our demo app. In the tutorial, we walk you through the instructions of installing kubectl, minikube, and installing Cilium as a daemon set. For the sake of time in this video, we'll just show that Cilium is already installed and running as a daemon set. Here at the Cilium project, we like to use Star Wars to make our demos a little more fun. In this case, we use a scene from the Star Wars Empire Strikes Back movie, where Princess Leia, Chewbacca, Lando, C-3PO, and R2-D2 need to escape from Cloud City, which has been overtaken by Empire forces. As they're trying to rush off and get to the Millennium Falcon, they're unable to reach it because the security access code on the door to the space pad has been changed. However, in the movie, R2-D2 accesses a public network terminal and uses that to override the access code on the door. And the rebels are able to get to the Millennium Falcon and escape. So how is this possible? Well, in this scenario, we'll see that the management of these doors in Cloud City is actually managed by a gRPC-based service. Here we can see the definition of that gRPC-based service, which is written in protobuf format. We can see a service that's the door manager that specifies a certain set of methods. Some of the methods are quite simple, like getting the name of the door or getting the location of the door, while others are more complicated and more security sensitive, such as setting the access code for that door. In this scenario, we set up two containers. The first represents the door manager service. Containers running with this service have the label app equals cc-door-manager. And it's running a service on TCP port 50051. Then we have a terminal container that represents one of the many public terminals in Cloud City. In particular, this is the one that R2-D2 plugs into, terminal 87. This and all other terminals have the labels app equals public-terminal. And we can see that this container can make all of the calls to the door manager service. So to try this out in practice, let's go over to our window and we will go create these two containers. What we can see is that we've created two containers, right? One is the terminal 87 pod, and one is the door manager pod. We've also created a service here that allows the terminals to reach the door manager service. Next up, we want to test access between the gRPC client and the server. Note that at this point, there's no fine-grained Cilium application-aware firewall in place here. So first, let's try out this command, which is running a command within the terminal 87 pod, and it basically invokes the door client, gRPC client, to call getName on door number 1. We can see that it responds with the door's name. Similarly, we can call getLocation, and it returns the location of the door. So far, both of these calls make a lot of sense. It's very logical that a service would want to allow a public terminal to be able to access information about the door's name and the door's location. However, as we saw, the service also exposes more security-sensitive calls, such as the ability to actually set the access code on the door. We can see here that the public terminal container also has the ability to set access codes here, which is exactly what R2D2 did when he overrode the security and opened the door for the rebels. So how can we lock down the network between these microservices such that the innocuous calls like get name, get location, request maintenance are allowed, but more sensitive calls, including set access code, are denied? Well, this is where Cilium comes in. Since gRPC is built on top of HTTP2, we can actually create HTTP-aware network security policies within Cilium and use that to allow and whitelist the calls that we want to permit, and the remaining calls like get status or set access code will be denied implicitly. So here's an example of a Cilium network policy that does exactly that. We can see we use the endpoint selector to select the door manager pods, and these are ingress rules, so that means that applies to traffic going into the door manager service. And we can see that we're saying that connections from any pod with the label public terminal, right, coming in on port 551 over TCP, we're going to explicitly whitelist the following URLs, which represent the get name, get location, and request maintenance gRPC calls, and all other gRPC calls will be implicitly denied. So let's go apply that policy. We now have created a Cilium network policy that corresponds to what we saw above. And then we're going to rerun those above commands. So first off, let's confirm that we can still do the types of calls that we're supposed to, like get location. We can see that get location is still working. Now let's try the security sensitive calls, like set access code, that we are intending to deny with our Cilium network policy. We can now see that with the Cilium network policy in place, we actually get a deny when we try to access that sensitive gRPC method. So with that, we've completed our simple demo of how Cilium can help you lock down a gRPC-based service. You can learn more and ask us questions by following us on Twitter using the tag @CiliumProject, or you can join us on our Cilium Slack. You can reach that at www.cilium.io/Slack. And again, if you want to try this demo out yourself, I encourage you to go to www.cilium.io/try-grpc. Thanks.